So this is a tutorial about the details of the asset administration shell. It is about the information model, the meta model of the asset administration shell. So it explains how to come from the concept to the UML specification. For whom is this tutorial? So it's not a motivation about why you need digital twins. You should already have an idea of the benefits of introducing digital twins to production. And you should also have some basic knowledge about the asset administration shell itself. And it would also be of benefit if you have some basic knowledge in UML modeling. Yeah, the motivation should be that you want to learn more about the underlying information model of the asset administration shell. And if you are a security expert, I'm sorry to say that this part of the meta model is out of scope of this tutorial and will be part of a separate tutorial. Okay, let's get started. But before getting started, some preliminaries. So first, of course, you could download the specification itself. I will explain the details and how to read the specification. And you should also, or could, if you have a UML modeling supporting XMI import, you could also download the XMI format and import it into your own UML modeling tool. I can show you also in GitHub itself. So this is a admin shell.io GitHub repository for the specifications. Here you have all the schemas, the JSON schema, the RDF schema, the XML schema, but also the XMI format that was exported from the UML tooling. Of course, it's better to get it from the release. Here you find the releases. Just download the latest release and then import it to your UML modeling tool. Okay, then UML. So there are some specifics in how we use UML, so that's why I will point out some of these specific ways of modeling. As you see here, it's explained also in Annex D, and it's also part of the XMI that I just mentioned. And of course, here you just start with the composition. So you need to know that these three kinds of modeling are identical, so they are all expressing the same kind of composition. It's the same for inheritance, so these are also three ways of representing inheritance or generalization in the UML tooling use. So this is a little bit specific for Enterprise Architect, the tools that was used for modeling the asset administration shell meta model. So this means that class 3 is inheriting all the attributes of class 1. And here you see how it's denoted if you make it explicit what was inherited from class 1. Very important concept for the asset administration shell is the shared aggregation. Here you see it. These three kinds of modeling again are identical. References are specific for the meta model of the asset administration shell. I will explain references after. So this is a very important concept to understand to really implement the asset administration shell as it is intended to be implemented. Enumerations are also, these three kinds of representation are again identical. So sometimes we use this representation with inheritance, but it's just for maintenance reasons. So in reality, what is meant is that this is an enumeration of A and B, and enumeration 2 is only B. So it's quite the opposite of the other of class inheritance. You will also find in the specification in Annex C an explanation of the templates used in the specification for explaining all these classes, attributes, and relationships. And here again you find there is a column kind, and these are the three values for kind and ref. with a star behind again means, so this is an important representation. If there is a star, it means that it is a reference as explained before, and I will explain it in detail in some minutes. Perhaps we just have a look at the specification itself. So the specification, the UML specification you find here in chapter 4. And if we just have a look, for example, at the asset administration shell, that's the way it's always explained. It starts with an overview of the classes. Here is the class asset administration shell with all its compositions and aggregations or shared aggregations. And this is a table as explained. Ref is a reference to another asset administration shell. These are aggregations. Aggregation is a composition, so a non-shared aggregation, and ref is, as I said, a reference. So this should be known how to read these tables. Okay, let's continue. Now, okay, I just showed it in the specification itself. So this is another example also out from the specification. First you see the class, and then you see the table explaining the class. So this is just to not get confused. The reference element is not a reference as I just explained it before. This is a submodel element. That's something different. Okay, so these were just some UML basics to understand and to know how to read the specification. And now let's get a little bit warmer. So this is now the complete overview of the asset administration shell Metamodel with the most important classes. I think the most what you see at one glance is that the asset administration shell is consisting of submodels, and the submodel is consisting of submodel elements. And one of the most important or typical submodel element is the so-called property. And then, of course, as you know, the asset administration shell is representing an asset, and the information with respect to the asset is stored here in the asset information class. So this is just the overview, so I will get into the details now step by step. To do so, we have to go through the classes that are inherited by many of the classes. So if we go back, you see here that asset administration shell is inheriting the abstract class. So all these classes that are inherited are abstract. So asset administration shell is inheriting from abstract class Identifiable and from abstract class HasDataSpecification. View and submodel also inherit from HasSemantics. Submodel is inheriting from Qualifiable and so on. Though these abstract classes are very, very important to understand the meta model of the asset administration shell. That's why we now start with these classes, and also in the specification you find a complete chapter explaining all of these abstract classes chapter by chapter. So let's start with identifiables and referables. That's of course very, very important. Identifiables are elements that have a globally unique identifier. So this is here the identifier. Here you see it. An identifier is a pair of an ID, the ID itself. It might be an IRDI or an IRI, and the ID type. Yeah, that's it. And then we have the referable. That's also, so an identifiable, of course, is also referable. Referable means that you can make a reference to this element in a unique way. But a referable does not have a global unique identifier itself. It's only unique in its context. So you have to have an identifiable available so that you can uniquely address also the referable. So here it's the attribute ID short that is the most important to know for the referable, so to make it unique. Another important concept are qualifiables. Here you see that qualifiable is a constraint, and that might be a qualifier or a formula. for qualifier, it's just a pair of, again, a value. Although it's not looking like a pair, but the most important attribute is a value. And the has semantics again. So has semantics, we are coming to this later, explain what the qualifier means and how the value is to be interpreted. And here it's an extract from the ICCDD dictionary, and here you see there are 5 qualifier types standardized already, and probably the most important and known one is the lifecycle qualifier. So this is something like as planned, as produced, and so on. Formulas, in contrast, are mainly used for security, for defining access permission rules. And a formula might, for example, express that a subject who wants to access a submodel is only, or wants to execute an operation X, is only allowed to do so if the machine is not running. And this means if the status of the machine has a value different from running. So both is possible. Qualifiers as defined in ICCDD, or also proprietary qualifiers and formulas. Now, one of the most, I would really say, one of the basic concept of the asset administration shell, because we are always saying it's about interoperability, that's the semantic ID. The abstract class has semantics. So here it's an easy example. A submodel element, a property, again, is a pair, a value, and a semantic ID. This semantic ID, again, is a globally unique identifier. And this, if you look it up, for example, in this case, it's an E-class identifier, then you will get the information like here. You would know R, it's a maximum rotation speed, it's measured in rotations per minute, and here you get the English definition, but in dictionaries you also get the definition in other languages, for example, in German, in Chinese, whatever language you need. Then what is also supported is our annotations or extensions, they are called here. This is something that is not standardized in a way, so it's not really about interoperability, but it allows you to extend existing elements with additional information that you need for your own use case, tooling, whatever. So this is to allow proprietary extensions. And this is the abstract class HasDataSpecification. It's inherited by several classes, but up to now we only have data specifications predefined for so-called concept descriptions and not for the other elements. And you see here that in the schema, in the XML schema, you see the schema is divided into 3 parts. The asset administration shell itself, then the security part. So ABAC means attribute-based access control. And then we have a data specification here. It's a data specification IEC 61360 for expressing concept descriptions according to the specification IEC 61360. And data specifications are meant to add attributes in a standardized way to existing classes. Another abstract class is the class HasKind. I put it together with the asset kind because that's often mixed up. The asset kind has the 2 values asset type. We speak about asset types and asset instances. In a way, that's about the life cycle. So a type is typically an asset during the engineering phase, and then you produce the corresponding product, and then you get product instances, and then we are speaking about asset instances. Modeling kind is a little bit different. Here we talk about templates and instances. So templates are something to express how a submodel should look like. And there are, up to now, there are for 2 standardized submodel templates available for the digital nameplate and technical data. So, but for asset administration shell, the default is always that it's an instance. An instance is a submodel where you get all the values and that is giving you the information about the asset you are looking for. Now we come to the referencing. As I said, that's an important concept for shared aggregations. And here on the right side, you see it. A reference is an ordered list of keys. And you can either reference referables. Here, that's a list of all referable classes in the specification. Or you can reference, of course, identifiables. These are the 4 identifiable elements in the meta model, but you can also reference something completely outside of the meta model. And in this case, it's the key element type is global reference. A fragment reference is used to point into a file. So it's a fragment ID, as you see here. So this is a key type and ID type in a way. Again, we have IRIs, IRDIs, custom specific identifiers, but also a local identifier ID short. As I said before, if you want to reference a property, you first have to reference, for example, the submodel, and then you can reference the property itself via its ID short. And if you reference a file, you can go one step further and reference an entity within the file with a fragment ID. That's how it's meant to be used. Here it's an example for the referencing. We just look at the examples themselves. So this is the grammar, how to do it. So here you see a reference. It's an IRDI of E-class to a concept description. The same thing for a global reference. So concept description means that it's part of the asset administration shell according to the meta model of the asset administration shell, whereas global reference means it's something outside and you are not copying it into the asset administration shell instance. And here you see a property reference via ID short, the temperature that is part of the submodel with this IRI with URL. So this is how it's done in practice. And now we dive in. So now have a look at the asset administration shell itself. I already explained it in a way. So we have the asset information. So here it's important to see that besides the asset kind I already mentioned, type and instance, we have a global asset ID and specific asset IDs. So because a global asset ID is really a globally unique ID for the asset. An asset may have several asset administration shell during its life cycle, but the asset ID is always unique. It's optional only in the meta model because at the very beginning, when you start engineering a new product, you might not yet have the global asset ID available. And that's why it's optional to also support this phase of the life cycle. But later you should really add a global asset ID. Specific asset IDs are identifier key value pairs, and this is meant to also add additional asset IDs that you use, for example, in your own company, or you could use the specific manufacturer ID, the supplier ID, whatever you want to. And then there is also the bill of material. I will explain a little bit later. And there is also a default thumbnail if you want. This is, for example, if you have a look at the asset AAS X Package Explorer, there's also a nice thumbnail that you could use for this. And then there are views. That's just a list of referables, references to referables. Okay, the submodel, okay, that's really easy as you see. It's just a set of submodel elements. It's a composition. And as you see, a submodel element is qualifiable. It has a semantic ID. It has a kind, template, and instance, but the default is instance. And the same holds for the submodel itself. And the submodel as well as the submodel element should always have a semantic ID. So now we go through the list of all the submodel elements. Here you see the list. This is the extract from the specification, and that's from the XMI UML in modeling if you imported it to your tooling. And now here is the overview of all the submodel elements we do have. So first we have data elements, we have properties, multi-language properties, ranges, blobs and files, references, a reference element, so that's something to reference something via logical address, whereas a file or also a blob are something physical, though there the value is something that you can really access. Then we do have relationship elements, we have capabilities, a collection, that's very important for structuring the complete submodel element or the submodel in itself. So the submodel does not contain another submodel. So for structuring, it's use the submodel element collection. There are operations, entities, and events. We will come to them a little bit later. So let's start with composites. Also, this is perhaps a little bit more complex, but it's typically something that people ask very, very often. How do we deal with composites? And of course, there are complex and composite assets, but you will not find an asset administration shell that is directly containing another asset administration shell or something like this. How it's done is via so-called bill of materials. Here you see them. It's not only one bill of material, it can be more than one bill of material depending on the relationships and the entities you want to express. Here you have a very simple example. This is a complex robot system. It consists of 3 parts. This is specified in the bill of material. And you see of the 3 parts, only 2 of them have an own asset administration shell, G and L. This we call self-managed entities, and the entity T does not have a own asset administration shell. We say that's a co-managed entity. And here you find it. This is an entity. This was a submodel element, and it has the entity type co-managed or self-managed as explained. And in this case, it might be a relationship like part of or consists of, and this is the relationship element. So a bill of material typically consists of entities and of relationships between these entities. So now we come to concept descriptions. So concept descriptions can be used to as a reference for the semantic ID. And there are 2 predefined specifications, data specifications. Here it's a one for IEC 61360. That's for describing the semantics of properties. So as you saw before, this is a typical concept description with a data type, unit of measure, and a definition, a preferred name, that's the maximum rotation speed, and so on. So this is expressed via this template. Okay, so these are now the basic concept of the Metamodel. And now if you want to create your first digital twin, you may use the AAS X Package Explorer. I assume you already tried it out, and then you probably already met all the attributes and classes I just mentioned. And here you see the technical data. These are mainly static information about the asset, and here you see the thumbnail. And I really would recommend that you use it, because then you will learn the Metamodel in more detail. Yeah, and if there are still questions with respect to the Metamodel or how to do modeling, then there is also an FAQ, a frequently asked question list in GitHub again. There you find already answers to typical questions that people are asking us, but you may also ask additional questions and we try to answer. Okay, and then of course, finally, I would like to mention the Industrial Digital Twin Association. That is the one-stop shop for the digital twin, and will also provide more screencasts and trainings about the asset administration shell. Thank you.